chapter 5 already, which is about input-output devices. So today we will look at what kind of input-output or I/O devices do we have. So we will look at the hardware and the software, the way they operate and the way the operating system controls them. So the operating system controls all the input-output devices, and so it is responsible for controlling them. It must issue commands to the devices and handle any errors that are raised by the devices. So what kind of devices do we have? Input-output devices are, for example, keyboard, mouse, modem, scanner, printers, network interface cards, USB devices, the bus, and just any type of device that is external device is an I/O or input-output device. So input, output, for short we'll call it I/O. The operating system has to control all the computer's I/O devices. So the operating system, it must issue commands to the devices, handle interrupts, or catch interrupts, and handle errors. So the handling of input-output devices is a significant portion of the operating system code. So what are these interrupts? So it issues commands, the operating system issues commands to the devices, handle errors, and catches interrupts. We have seen before that the speed of the CPU, the speed at which the CPU operates, is much faster than the speed at which the external devices operate, or the I/O devices. So when the process had to perform an I/O operation, let's say had to print something at the printer, then by the time the printer is done printing, the CPU has to stay idle because the printer takes so much longer than the CPU does. So instead, we would just stop that process until the I/O operation is completed. And when the I/O operation is finished, and we can return back to the process where we left off. So the operating system has to handle these interrupts. We have two types of I/O devices. The first ones are called block devices, which the block devices store the information in a fixed sizes or blocks, and then we have character devices, which accept a stream of characters. So, the block devices will store information in fixed size blocks. Each block has its own address. The size can be, for example, 512 bytes up to 30, for example, or 32 kilobytes. Could you think of an example of such an I/O device which will read and store information in fixed size blocks?
CD-ROM, is that right?
Okay, CD-ROM is one of them. Anything else?
Flash drive.
Hard drive, right? That's what the disk. That's what we've seen last time. We have seen that when we write information to the hard disk, it is in blocks, and each block has its own address, and the hard disk is an I/O device. Anything else? Something that we carry around in our pocket?
Flash drive.
Yes, flash drive or USB drive is another I/O device that stores information in blocks. And the other category is the character devices, so delivers or accepts a stream of characters. There is no block structure, and it is no addressable. So, could you think of an example of a character device then? We have some on the screen here. So look at this list. Are any of these devices accepting and delivering information as a stream of characters? One more time. I didn't hear. Scanner?
Oh wait, you mean the physical device scanner?
How about the keyboard?
Oh wait,
Does accept a stream of characters.
No, they don't accept any information, they only output information. Same thing with answers.
Yes, so the output information as a stream of characters, right?
Well, they output information, yeah.
So one is the keyboard. Scanners, printers maybe? Yes? Printers will print text or characters. Scanners with the scan text, yes. And even the network card can accept or output a stream of characters, correct? Very good. So, these are the two main categories that we have here. Now, these devices consist of two components. They have mechanical components and electrical components, which means they have the actual physical device, and then they have some electronics components built into them, which allows the operating system to access them and control them. So they consist of mechanical components and electrical component called the device controller. This device controller will convert a serial bit stream into a block of bytes and it handles errors. So some low-level error handling is done inside the I/O device itself. But however, if the device cannot handle the error, the operating system has to handle the error. But first, we try the actual device error handler that is built into it before the operating system error handling will kick in. So it does have some low-level error handling built into it. So this device controller is the way that the operating system would access and control the device. So it does have several registers built into it for the CPU to access them. So each controller has a few registers that are used to communicate with the CPU. By writing into these registers, the operating system can command the device. So by writing the registers, the OS can tell the device what to do. What would be an example of an operation that the operating system is asking the I/O device to perform? So it writes into the registers inside the device controller, and it wants to issue a command. What kind of command would it want to issue? If I want to switch on the device, right? If the device is off, so that's one example. Switch on or off. Anything else? If it's a printer, then what?
Mode of operation, whether or not it's scanning or it's copying.
Yeah, so we want the device to accept data, for example, which we're submitting to it, or to deliver some data to us. Let's say if it's a scanner, it has to output the information that it scanned. So either accept data or deliver data. Or just any action that the device needs to perform would be done by OS writing into the device registers. By reading from the registers, the operating system can learn about the state of the device. So whether the device is ready to accept data or if it's busy doing something else at this moment. Many devices have a data buffer where the operating system can write something to it.